Jain viewers, welcome to AKGC Digital School. My name is Pankaj Singh, faculty of IT department. Today I am delivering my video lecture on a topic Hadoop architecture. Basically it is a topic of cloud computing. So before going in depth, first of all we will take the outlook of our presentation. What will I deliver today? Today I will discuss introduction to Hadoop, then in detail Hadoop architecture, Hadoop components, what are the basic components that make a complete architecture of a Hadoop, and then the basic application that we are using in a day by day use, or we can say in our daily uses if we are using a digital platform different like Yahoo and Facebook and different social media sites. So now we start. Here, what is Hadoop? First of all, I will give you a brief introduction about the definition of a Hadoop. So here I read out what I put in my presentation. Basically, Hadoop is an open source software framework that is used for storing and processing large amount of data in a distributed computing environment. So it is designed to handle big data. Here I underline few terminologies that are used here to handle big data, and is based on the MapReduce programming model, which allow for a parallel processing of large data set. So now in a first line that is written here, open source, that is used for storing and processing large amount of data. What size of data? Terabyte, gigabyte, such large size of data size is processed and analyzed for the business purpose or for their different uses of their organization. So by the size we are easily understand what size of data is processing in a Hadoop. It is a open source software, as we heard the name Apache. In Hadoop we use generally Java language to process or storing the data. Here Hadoop is I read the second line here. Hadoop is an open source software programming framework for storing a large amount of data and performing the computation. Its framework is based on Java programming with some native code of C and shell script. Actually in few libraries and in few parameters in modules we are required other support from the different language like C and shell script. So take the second slide here. So what is the basic full form or abbreviation of Hadoop is? Hadoop is a here high availability distributed object oriented platform. Here each word have its meaning. High availability, because the size of data is too large and we need to process data as soon as possible for the purpose of analysis in a business field or in a government field where data in real time is required. Hadoop is an open source framework, as I said earlier in a previous slide. Hadoop use distributed storage and parallel processing. What it mean here? The size of data, for example, the size of data is 10 TB. So this data will be stored at a 5 different storage place. Why it is do? So that we can easily independently process 2 TB here, 2 TB, 2 TB, 2 TB and 2 TB at 5 different cloud locations data is putting, and to process this data parallel processing is used to handle big data and analysis job, breaking workload down into a smaller workload that can be run at a same time. For example, if a server having a data of 10 TB, to process this data on a single machine, it will take, for example, 1 hour. But when we distributed this data into a 5 nodes and we are using parallel processing to process this data, so I will take a hypothetical data that will be execute in a, for example, in a 20 minutes, because at a place of one machine we are here using 5 machines. So that is the basic difference between the server running data availability and in a Hadoop running availability. So it is very clear to the viewers why we are going to opt Hadoop, because it stores data in a distributed manner and process it in a parallel manner. But if we store the data on a same machine and process on a same machine, it will be in a serial manner and it will take more time as compared to the Hadoop approach. Now we will discuss, as I said in my introductory slide, we are discussing here Hadoop components. Hadoop have four components. First one is MapReduce. Second one is Hadoop distributed file system called HDFS. Then yet another resource negotiator, Yarn, and Hadoop common. These are the basic 4 components by the help of which complete Hadoop system, or we can say architecture, is designed, or we can say these are the minimal requirement to perform the Hadoop operation on a data. So have a look over the Hadoop architecture. As we see in a slide, the Hadoop architecture consists 4 components. First one is a MapReduce. It work on a distributed processing. Then next component is HDFS, that is a basically used for storage, and Yarn, yet another resource negotiator, that is used to schedule the job and resource management. And Hadoop common, what it is basically, it contains the Java library that support to execute all the operations relevant to these connected components and the data available for processing and analyzing in a Hadoop architecture. So we will take one by one in a detail what exactly MapReduce do, what HDFS do, what Yarn do, and what is the basic role of Hadoop common in a Hadoop architecture. So now have a look over the MapReduce. What is MapReduce? As we see in a block diagram of MapReduce, we see here there is the big data, the node from which we will pick the data and process. These are the processing approach, or these approach technically we can say these are the algorithm. What we exactly do in MapReduce, it is just like algorithm or a data structure that is based on Yarn framework. I will discuss Yarn framework in detail in a next PPT. The major feature of MapReduce is to perform the distributed processing in parallel in a Hadoop cluster, which make Hadoop work so fast. As I said earlier, it divide the data into small chunks, or we can say clusters, to store at a different locations and then pick it and again combine, so that the valuable information is fetched from the different locations. And for that we are using 2 terminologies here, map and reduce. Generally it is called together, it is MapReduce, but in map there is another function, and in reduce there is a different function. So first of all, I read the basic function of map and reduce. The map function here break this data block into a tuples that are nothing but the key value pair. These key value pair are now sent as an input to the reduce. What exactly do? The chunk of, for example, 2 TB data is divided into a set of tuples, like here map 1, map 2, map 3. and in a reduce function, then combine this broken tuple or key values pair based on its key value and form a set of tuples and perform some operations. Like what type of operations is performed after reducing this data? Like sorting, summation type, job, etc. So if we are performing Excel, or we can say sorting operation on a 2 TB data at a time, it will take more time. But if we break it into a chunks or tuples, the size will small, and as we know that the algorithm will work faster as compared to the large size of data. And after that, the valuable information is fetched and it will reduce into a small size, and that will be helpful for the organization, or we can say for commercial purpose. If we are analyzing any website data, for example Amazon, or we can say Flipkart, like that, and that will give a consolidated output that will help for any analysis of the users. So that is a basic operation will perform in a map reduce. That is basically the implementation of algorithm, and these algorithm divided into two parts, map and reduce. In map part, the size of the data is break into a tuples, or we can say different chunks, and then it will again combine. The size of data will reduce in term of information, and that will be helpful for any organization. After that, the second terminology we read here, that is HDFS, Hadoop Distributed File System. What it is? That is basically a repository, or we can say a cloud hardware device where all data will stored. I read the few points regarding it. HDFS is utilized for storage permission. As I said, it is a mainly designed for working on commodity hardware devices. HDFS is a Hadoop provide fault tolerance and high availability to the storage layer. By using this mechanism, the storage of data is highly available and the possibility of fault tolerance is minimized. And the other device present in a Hadoop cluster, data storage node in HDFS. Here two terms are used, name node and data node. Name node work as a master and the data node work as a slave. Here one of the master that will control all the data repository stored in a HDFS. Name node, what name node will do? Name node work as a master in a Hadoop cluster that guides the data nodes. At what time data will be picked and which server will access and which one have the right to process this data. The all control is done by the name node, and relevant data repository is maintained at a data node. Data node work as a slave data node, are mainly utilized for storing the data in a Hadoop cluster. The number of data node can be from 1 to 500 or even more than. As we know that if we cluster the data at number of positions, the access time will be minimum, but the latency time will increase because that's depend upon the type of service provider which provide the at what speed to the user. But as the node will increase, for example 1 to 50, 1 to 500, the access time will be very low because the size, as we take the same example 1 TB, if 1 TB placed at a 10 node and if it is placed at a 500 node in a distributed manner, if we access it from the 500 node, the access time from one node is very fast as compared to the 10 because the size of data will matter. It is a basic architecture of HDFS in which, as we see, there is a master which manage all the slaves or nodes that are related to the master. It will put the data here. We have 3 slaves, 1, 2 and 3. This slave store all the data that is relevant to the master or the operator who operate all the concerned bulk size of data of any organization. It will put at a slave 1, slave 2 and slave 3. So for example, we have 3 TB of data. So if we stored it in a uniform manner, so 1 TB will go there, 1 TB here and 1 TB here. So if we access, as I said again, if we access 3 TB from a one node, it will take more time as compared to the 3 node. That is very clear. So if we access 1 TB from here, 1 TB from here and 1 TB from here, the processing of data is fast as compared to the other method. So these are the first two components of a Hadoop architecture. First one is MapReduce and second one is HDFS, Hadoop Distributed File System. As the name suggests, all the data will be stored in a distributed manner to make it fast access from the node, and the node may be vary from 1 to 500. Now we will take the third component, YARN. What it is exactly? That is basically a framework, or we can say interface tool by the help of which user can, here user means here the admin or the operator who manage all the data of a organization. What can he do by using YARN? Yet another resource negotiator. As the name suggests, and we will study all these topics in detail in operating system, what is job management and what is resource management. So basically it works as a negotiator, how to use the job and how to manage the resources that are available in a cloud architecture. YARN is a framework on which MapReduce work. YARN performs two operations, that are job scheduling and resource management. What we will do in a job scheduling, as we know that is a topic of operating system, but I will take here a overlook of it. The purpose of job scheduler is to divide a big task into a smaller job so that each job can be assigned to a various slaves in a Hadoop cluster and processing can be maximized. As I said earlier, it work on a distributed manner. The task is divided, job is divided into a clusters, and the processing, but obvious, will be fast as compared to the single task. And the resource management is also matter in a cloud computing architecture. And the use of resource management is to manage all the resources that are made available for running a Hadoop cluster. Within a Hadoop architecture, there are different resources is required to execute the or to perform the data processing on a bulk size of data. So it work as a manager that operate or customize all the requirement of a Hadoop architecture in term of a job and in term of a resource, because that is the illusion. If we are using a cloud architecture, the all resources are available in a unlimited manner, but that's not a fact, because if we are using resources in a unlimited manner, the cost of access the service will increase very more. So if we are using cloud architecture, so how to manage resource efficiently so that they will give a max output in a better way. So to manage resource and job scheduling, we are required YARN, that's known as yet another resource negotiator, in which resource and job are organized. As we know that, I will take the example here. If we have a J1, J2, J3, J4, J5, these are the job, and job 1 and 2 will run on a machine M1, it will run on M2 and it will run on M3. If suppose we have only one machine, so what will happen after the execution of job 1 and 2? job 3, 4 and 5 will execute. But what will here, what exactly do here? In a parallel manner, the other 3 remaining job is also executed. That is the advantage of yarn, or we can say the advantage of Hadoop, because in which we are divide the job in a small clusters and execute in a different machine in a parallel manner. And what are the advantage? But obvious, if we are using in a distributed data at a parallel way, or we can say at a parallel machine, there are few advantages, or we can say feature of yarn: multi tendency, scalability, cluster utilization and compatibility. These are the advantage, or we can say the main features of a yarn as compared to the normal architecture. What is Hadoop common? That is the fourth component of a Hadoop architecture. Hadoop common or common utility are nothing but our Java library and Java files, or we can say the Java script that we need for all of the other component present in a Hadoop cluster. These utilities are used by HDFS, yarn and MapReduce for running the cluster. As I said in the beginning, it is nothing but that is the repository of all the Java libraries that are required to execution, or we can say the support libraries to execute of MapReduce, yarn and HDFS for running the data that are stored at a different clusters. Hadoop common verify that hardware failure in a Hadoop cluster is common, so it need to be solved automatically in a software by Hadoop framework. That also helpful if, for example, if any node is fail in a architecture, so it will recover by the help of Hadoop common library files that are stored in a Hadoop common, that will assist or help to recover the node as soon as earlier, because if it will not store it there, that will be done by manually. But in case of using Hadoop common, all the operations related to the recovery will execute parallelly, or we can say in automatically mode as written here. So these are the basic 4 components of a Hadoop architecture: MapReduce, HDFS, yarn and Hadoop common. In a brief description is written here along with the slide. Now have a look about the different applications, or we can say where Hadoop is used. Hadoop is used at the most of organizations that handle big data like Yahoo, Facebook, Amazon, Netflix, etc. Mostly social media sites use Hadoop to analyze their data in a parallel way as soon as possible, or we can say in a fast manner, and that is achieved by the help of Hadoop. And Hadoop consists, and it is possible in Hadoop because of their 4 components: MapReduce, HDFS, yarn and common library. The cluster or the combination of these 4 components make a strong architecture that's known as Hadoop architecture. What size of, as I said earlier, what size of data is handled in Hadoop? For example, the Facebook Hadoop cluster hosts 100 plus PB of data July 2012 and growing at half PB per day in a November. It is a data available on a website that I put into a slide for an example to show that how large size of data is processed in a Hadoop and why we required Hadoop. That is very clear from the size of data, because in big data the real time analysis of data is not possible. For real time analysis of data and quick analysis of data, we required Hadoop architecture, and Hadoop architecture consists 4 components. For, as I said, if we are doing something, there should be some reason or some motive behind that. There are mostly commercial reasons, for example, advertisement, search and security. So if we are doing such large size of data analysis, it will use somewhere and it will help for any organization in any manner. So we can say that the main application of Hadoop in today's era is advertisement, search, and security for uncommon pattern. So hopefully from this video lecture, two things is very clear: what is Hadoop and the components of Hadoop, and third thing, the application and the area where Hadoop is used, and why we use Hadoop, because of the large or bulk size of data that is in a terabyte, petabyte, and so on, gigabyte. So thank you for today. We will meet in a next video lecture.